Okay, let's get started. And today we have the very last Android lecture, although it says Android Introduction on the top here. I've got about 3 or 4 of these things I'm going to go through. I'm going to use today as a review day, sort of. Next week we're going to see what's on the final exam. But this week is just primarily going over some loose ends and catching up on some stuff I didn't give you throughout the course. Or stuff that I felt was important and something that you wanted to remember, or should know for the final. So today's lecture is, it says introduction up there, but it really isn't an introduction. What I want to do is kind of thumb through this kind of quickly, because we've seen a lot of these concepts individually, but we haven't seen them put all together in terms of the big picture. So the focus of this lecture, and one of the other things I forgot to mention as an announcement, I'm putting, supplementing what's up there on BHECR throughout the week, this week. I'm also getting it into the LMS or EMS, which I don't believe it's in the EMS yet, so that you guys know where to find this study stuff, because nobody ends up studying until the week before the final exam. And so next week I'll be going over the final exam with you, so you'll probably want to find the materials, so I'll have that all ready for you as well. But proceeding with today. What the goal of today's understanding applications are, in terms of what, although this is really a beginner kind of lecture, I don't believe I've gone over this with you, and I probably should have many weeks ago, but now's a better time than ever to catch up with it. So in terms of the concept, we looked at, and this is a great way of reviewing actually as well, so we looked at the activity concept, so I'm hoping you're familiar with that at this point. And we looked at services as well in terms of the implementation. So this is going to really compare activities with service with broadcast receivers, with content providers, with intents, and then a little bit more on that Android manifest, in terms of the big picture of how it works. And these are the components of the applications we're building, and they're components that are interfaces for different features, and believe it or not, that's the inclusive list. You really can't do anything else. And what I mean by components, it's how one screen or one class is working with another one, which is interfacing with another one, and so forth. And one screen, for example, if we talk about intents for a second. Oh, thank you. Intents being this item down here towards the bottom. We've seen this in a couple ways with one XML interface screen calling up another interface screen, or we can also do it without the screens. We can have intents call processes, start processes, make instances of classes, run different functionality. And we know that the manifest is the one that's keeping all of the permissions we've seen so far throughout the course. So we know that the role of that as a component is to organize the features and the access that this application is going to have. In terms of content providers, this is the stuff that's really easy, actually. It's getting a hold of the address book. It's getting a hold of services that the phone, in terms of content. Well, what's on the phone? Tons of content, usually, or on the tablet. Pictures, media libraries. And so interfacing with that is actually a no-brainer. You just make a new instance of the object, and you go in and find what you're looking for. Broadcast receivers we saw with chat messaging, actually, with the SMS chats, because this is essentially what was giving us our ability to network back and forth between different devices in terms of broadcasting a message out to another, from client to client, another device to send a text message, or to actually would be the same thing for any type of other message as well. Services we've seen in terms of processes, and then the activity, which is the base, essentially. So I kind of went from the bottom of the list to the top of the list, but those are all of the inclusive list. Is what the reason why I went back to that slide was essentially to emphasize that point. So everything is written in Java, obviously, we know that already. One of the things I didn't mention earlier in the course is that we don't have to use Eclipse, actually. In fact, as long as you download the libraries themselves for Android and you have Java installed, you can actually work in a non-Eclipse environment using Notepad or a command line interpreter if you wanted to. Most of it is native code. It doesn't actually have to be. We didn't cover it in the course, and we're not going to cover it. But you could actually integrate other source code capabilities. So, sort of like the way you can do with an iPhone, actually. You can write C++ instead of Objective-C. You can actually use languages other than Java as well, depending upon what you're doing. You might want to integrate assembly language. You might want to integrate C or something in there. And so there's packages for that to integrate different language support. Obviously, what we covered in this course was just Java working in an Eclipse environment. There's a good separation, as we saw in the last lecture. I believe I gave you last week talking about, or week before, about security. So we looked at that as well. And corresponding security with other applications and processes and things that were going on. So that's another component. One of the things I probably mentioned in the beginning of the course, but I don't know if I really reiterated the point, but each process that's running on the system is actually running in its own VM. So it's kind of interesting how the Android environment is sort of different from a Java perspective than a computer environment. If we ran a Java program on your MacBook or on your Windows machine, it's running on the same VM as everything else that's running. You have one virtual machine that you load. When you load it on a Windows machine, sometimes you see that little Java little cup or a little guy that appears in the taskbar at the bottom of the screen. You don't get that in an Android environment. However, you get like 5 of them if you have 5 applications, or 6 of them. Sometimes you see that in Windows as well, multiples of it showing up, because the program could actually reload another VM. Why do you want different VMs? Well, the VM is the operating system. It's the environment, and you're setting environment variables and things that are accessible via the program. So if you have multiple VMs, in fact, this is why the security is actually so nice in this particular configuration. With multiple VMs, there's no need for a security file. So if you've ever done Java and you've looked at security and privileges and things, configuration is a nightmare, because you have to actually create this little text file and put it in certain folders and locations for the application to actually set its own application privileges, because it's all running in the same VM. So the translation of that on the Android system is essentially just create a new VM. So there's a new VM created for each one of them, and then the settings are actually held in the VM, and the manifest is the gatekeeper to that, which is kind of interesting. So the manifest really is your text file showing your permissions, your properties, but it's also setting the environment variables. So you can do a lot of things with the manifest. In fact, as an example, you can set the manifest to keep track of the version of the program. You can set it to keep track of information about the release, which platforms you want it to run on. There's a lot of different settings, and if you spend some time go through the API in terms of the properties and all the little features, you'll see there's tons of things you can set for those projects. So each process has its own separate VM. Each application is assigned a unique Linux user ID. So each application runs in a form of a process abstraction, and there's only one process running at a time during that application, which is kind of interesting, which is going back to this intent. You might think of the intent as a process synchronization mechanism. It's only going to load one process, shut down another process. Most people who end up with problems with apps that don't run correctly is because they finished one process in the application, but it's still running. And then they load another one, and then they get this lockup because the VM gets confused, and it says, well, wait a minute, which one is loading? It's only one process that's running at a time. Which one? And then the whole thing crashes, essentially. But yeah, there's not too many inter-process communication difficulties, because there's only one process at a time running, which is kind of interesting. So by default, files of the application are not visible to that application, but can be explicitly exported out of that application. But they're not visible to other applications either. So the files themselves that are associated with the user IDs have access in and out for the user ID purposes for whatever's happening within that application. So here's our application component summary, which I sort of wanted to give you as review. And this is good preparation for the final exam, because on the final I'm going to ask you, what's a broadcast receiver? What's a content provider? What are intents used for? And this is the testable material. I'll go over next week more details, but this is a nice review lecture actually. So starting with the activity, it's the visual user interface focused on a single thing a user can do. In fact, by default, that classes has the activity added to the end of it. Why they did that in Eclipse? Makes it easier, I guess. Kind of reemphasizes the point, actually. Services have no visual interface, so a service and an activity are really the same thing. but you might want to call one a foreground and the other one a background process. Think about it, because there's no user interface, they run in the background. So services and activities, kind of the same thing you get on a regular old computer, actually. Broadcast receivers receive and interact with broadcast announcements. What are announcements? Well, you send an announcement to a device, and then the appropriate service picks it up. And you can actually go through the notification. You can actually send it to the notification as a service. And notification could say, well, hey, this is a text message. Okay, send it to that text message program. Or this is an incoming call. Or this is a request to update this app or something. Then content providers, they allow the data exchange between the different applications. So sort of think of the content providers as the middleman who's sitting out there, not like a database, because databases, as we've seen so far, and we've seen this already. I do remember that lecture. We had storage was the topic, and we had files and databases and different kinds of files that I talked about that were specific towards the app, which is kind of interesting, because in any other environment, you use a database, you think a bunch of applications all share the same database, and one can write to it, the other one can read from it. No. If you think of the concept, because it's all loaded in separate VMs, nobody shares anything. So one app who creates a database and uses it for something doesn't use it like a traditional style database, instead uses it to store data instead of files, which is kind of easier. But nobody else has got any control over it. Nobody else has any access to it. Content providers are the equivalent to the old database. So what are they? They're shared by everybody. So the contact list, your names and addresses and telephone numbers of all your friends and stuff, that stuff is shared by every application on there, and every application can get to it. So for security purposes, sometimes you don't want to use a content provider, if you think about it, especially if you have like, you're saving personal information that the app's going to use. You put in a content provider, you pretty much put it in an open database that anyone who wanted to can go out there and get. But the purpose of the provider is to provide, if you think about it, so it's for public use. So getting used to that concept is kind of interesting, comparing it to databases. So here's some particulars about the activities. It's the base component, the basic piece of most applications. Most applications have several different activities that start each other as needed. You can have more than one activity. Although the first class that gets created in a default hello world or whatever it is you're creating, when you create Android project new, you get name of your project activity. You can actually create multiple activities, and you can actually change the name of that activity class to something else if you wanted to. If you're going to do that, you're going to use a feature called refactor. In terms of the refactoring, that I believe I don't know if I showed you that at all, but if you go into the menuing system, you'll see under refactor, there's a rename, where what it does is it goes through and changes the name of that class, if you're changing the name of the class as an example, to whatever it happens, whatever you want to change it to, but it changes it everywhere else in the program as well. So refactoring is a better way of doing it versus a rename, because when you set an activity, as an example, the activity is used as a basis for like main almost. It's like the main of the program. So in theory, you want to change it if you're going to change it, so you refactor. It reformats the project. But you can have more than one activity. You can have more than one activity class. Each is implemented in a subclass of the base activity class. You can have one class call another class as a subclass, and the activity class, if you haven't noticed, is also inherited from a couple of different classes. Did we have a problem in the back? I'm sorry? Yeah, hold on one second. Let me just pause this for a second. Okay, sorry about that. Let me resume. I didn't want to. Let's see. Oops. Hey, look at that. It actually goes back. PowerPoint doesn't do it. OpenOffice goes back where you left off. Interesting. PowerPoint doesn't do that. All right. I recently upgraded my computer, and I noticed that the Microsoft Office version didn't work with the Lion version I put on this thing. So I went back to openoffice.org. So I'm pleasantly surprised. Good idea. All right, so I was talking about activities in terms of the basic component, and knowing that an activity can be subclassed as well. activity actually does inherit. It can inherit from different um, inheritance lines depending upon the purpose and nature of that activity, depending upon what's going on. So in terms of the view, we have the view concept. So each activity has a default window to draw. So it's a prompt for dialogues or notifications or something. So we have a view concept that plays a part in terms of the role of the activity. And we can create views, call views, or talk about the view in terms of when we're passing information from method to method or class to class. We can actually tell it to use this view, use that view. And actually another concept that we've seen in practice, but I haven't gone over yet, which is also part of today, is the context and the this concept. And the concept being that what we're looking at is different perspectives. So in terms of the context, it's within this process, within this VM, versus a loading from, let's say, another intent or from another location. The view is usually referred to as the visual. It's the dialogue. It's the XML interface to it. And then in terms of being able to switch back and forth, that's where most of the confusion comes into place. So a lot of the method calls will be view V or context C or context with an uppercase context and lowercase context, where we're making instances of objects where we're sending information back and forth between different views or between different contexts. And then this can apply towards, in fact, you can do this inside of different contexts. And so this would be referring to as, same thing in Java as the current object. But usually in the Android environment, you'll see the name of the object dot this, just in case, because it's a great way of making sure that you're talking about the right this in the right context or in the right view, depending upon what you're doing. So most of the issues that come up when people start playing around with views, and we looked at views last week actually. When we start working with views, is what do we have exposure to? What are we sending? What have we received? And what are we doing in terms of the environment space or properties that are associated with the view? And so if you have a view and you open up a dialogue in the view, but it's a different view and you're trying to send information back and forth, then it kind of gets a little hairy sometimes. In fact, what ends up happening is Eclipse will give you a nice little error message that says, hey, this is not compatible, or wrong view, or specify the view. What view are you talking about? And you go, I don't know what you're talking about. Well, it's really referring to this particular concept. So the content of the window is a view or a group of views derived from the view or view group, as we saw last week actually. I believe I gave you views last week. An example of views are buttons, text fields, scroll bars, menu boxes, and things of that nature. A view group is made visible by the set context view method, where, content, not context. There's a context actually, to set the context. So not to confuse that. But the set the content view changes the view for the activity, because you can have more than one view that's associated with the activity. And so you set the content view to reassociate the environment space, if that makes any sense. Knowing how to do that makes your life easy, because then you can use one activity with multiple views and not have to create a ton of rework for yourself. Because what you want to do is kind of minimize the number of classes and minimize the number of views and things, and just keep reusing components and having it consistent. Otherwise, you end up having to reduplicate a lot of things. So services. Mentioned as ready, services are sort of like background processes, as we've seen. It doesn't have a visual interface to it. Can't have a visual interface, doesn't actually communicate. Services, are they really background processes? No. Yes and no. They don't run simultaneously with other processes. They occasionally wake up and do something, and then they go back to sleep. So as an example, your notification is a service. So the notification service is part of the content provider, which is part of, and another thing going back to that concept of the content provider, which is probably coming up as well, it's more than just content. It's usually services or features of the phone. As an example, something to pick up a signal, something to send a message. The notification is an excellent example of that as a receiver. And it's actually, you can use broadcast receivers, you can use services to send notices back and forth. in terms of the usage of that particular feature. Runs in the background indefinitely and doesn't ever go away. The way you make it go away is you kill it, or you have the app kill it. Otherwise, you know, I believe I went over the app lifecycle in terms of this particular foundation. So examples of the service is a network downloads as an example. Playing music, TCP UDP services, remember that. So you combine to an existing service and controls its operation. So when I say bind, it means it can communicate to an existing service. So a text message service, message notification, or broadcast receiver can communicate with the content provider, can communicate with a notification or something, and go ahead and provide information for that service. Broadcast receivers, another important concept to remember, especially for the final coming up. Receivers that react to broadcast announcements. Broadcast announcement, well, you can send and you can receive with a broadcast receiver. So it goes both ways. Extensions of the class broadcast receiver. Examples of broadcast receivers or broadcasts. As an example, a low battery. These are things that the services are broadcasting for your basic phone operations. The power is connected, the power is not connected, shutdown, time zone change, orientation change, which is part of the services that are associated with the info for the phone. Other applications can initiate broadcasts. You can actually create your own broadcasts. And so you can make your own instance of a broadcast object in your application and bind that with a service that's going on the phone so that your application can actually tell you there's a low battery or something, or you can actually combine those concepts if you wanted to. So content providers, so makes some of the application data available to other applications. As I mentioned before, it's kind of like the global databases, but it's not really a database, but it's global service provider / content for the entire phone or tablet, whatever the device is. It's the only way to transfer data between applications and Android. So no shared files, no shared memory, no pipes, nothing. No inter-process communication. So you use broadcast providers, or content providers to share information. An extension extends the class content provider. You can create your own content provider, or you can use some of the built-in content providers that are provided by the base operating system. Other applications use content resolver objects to access the data provided via the content provider. Because you have to resolve the location, you resolve the content from the content provider. It's just another way of, in fact, that's a newer way of doing it, a newer class that's been added to the library. Intents. So an intent is an intent object with a message content. Well, intents are actually used for practically everything. You can't write an application without using an intent, unless you're writing Hello World. Well, actually, you can write Hello World with an intent if you wanted to. It's kind of impossible. I mean, kind of stupid. You can actually take an intent and load a dialog box from it. In fact, I'm going to review the little dialog boxes for you in a few minutes. But alert boxes, dialog boxes can be loaded from intents if you wanted to. Or you could just load them from the current app. What does an intent do in theory? It's the way that I was mentioning before of switching one process to another. That's all it's doing. Why they called it intent? That's the intention to run this class. The intent to run that class, I don't know. I'm guessing on that one. Activities, services, broadcast receivers are started by intents. Everything is started by an intent, if you think about it. So that's the default option on a multiple choice question. What uses intents? Everything actually does. It's the only way you can switch from one running process to another is to use an intent. So even a dialog box is going to use an intent, if you think about it. Well, it's built into the, well, may or may not be built. It depends on what method you're using to load that dialog box. You can actually load a screen, a window, another class, anything you want. Okay, so what do we got here? Content providers are started by content resolvers. Broadcast services, activities. So activities, services, and broadcast receivers are started by intents. Content providers, however, are started by content resolvers, which is the more current. And as I was mentioning before, in the old days, everything was an intent. The current releases now, the modern day APIs that's out there right now, content providers get separated out, and now they're started by content resolvers. Because if you think about it, it's kind of a different concept. You're running something that's, and if you think of there's a good way of separating out the logic actually. Anything that's run inside of the process, going back to what I was saying about processes running in a separate VM and they're all by themselves and only one process at a time is running simultaneously. Intents manage that environment. Content providers don't run like that. Content providers run along with your application. So in your own little VM, intents manage everything there. Outside of your own VM, out in the real world on the phone, content providers, and then the content resolvers are the ones that are actually working. So that's going to hold everything else. So there's now two categories. So the activity started by a context, start activity, intent, just make an instance of intent. Context, going back to that concept, is sort of like, as I was mentioning before, there's similarities between views and contexts. In concept, the view is usually the visual, or it's the grouping of the visuals in terms of components. The context is generally the environment, which process is actually running in terms of its context. Because you can load different contexts depending upon what it is you're doing and have switch back and forth between the different contexts. As an example, if you're looking in, when I went over the databases, I talked about a database helper. So usually there's two threads that are running with that. So you have one that's creating a reading and a writing services to the database. And then you have another database helper class. And the database helper class is switching the context, is using a different context. And what it's doing is it's finding the database from the content receiver, from the content resolver, finding it from the content provider, loading it up in terms of its environment space, looking at it, managing it as a resource. And then you have the other contexts going back and forth in terms of the space for what's going on in the program. So that was used by a method called start activity for result. So we have a start activity for result, intent request code. So just start it. So a service is started by a context.start service with an intent. So an application can initiate a broadcast by using an intent in any of the context.send broadcast methods, or send ordered broadcast, or send sticky broadcast. It depends on how you want the broadcast delivered. Do you want the broadcast to go to a certain particular service? Do you want it to go to a particular application, a particular feature, content provider, whatever it happens to go to? So broadcasts are kind of interesting because they do fall into some different categories in terms of their usage. Shutdown components, or shutting down components, I should say. When we finish an activity, we finish, and we actually use the word finish. So it terminates itself. So when you're using an intent and you're creating a new intent, you're taking the intent and you're loading a new window, or a new class instance that's tied to a different window or different view associated with it, then you're going to finish. When you finish, it doesn't actually start. It doesn't actually. Hold on one second. Are you guys, the two in the back? Are you guys taking exams? Yeah. Can you separate by? I know, but can you separate? Yeah, sure. I see some information going back and forth. Yeah. When you give it, don't let them sit together like that. Yeah. Thank you. Sorry for the interruption again. All right. So let's see. So activities. So to terminate an activity itself, you would actually type, or you'd actually put in the code finish. It shuts itself down. It does not shut down the actual running of the program unless nothing else is actually loaded. So if a current activity finishes without loading another activity first, we end up with a program that just stops. And you go back to the main menu and or a home screen, and you're like, oh, what happened? And it's usually because your intent was in the wrong order. You finished before the intent was loaded. You can terminate other activities. It starts by doing a finish activity. So it can terminate other activities. It started by finishing the activity. Services can terminate via a stop self. Inside of the code, if something happens, you can say, stop. in terms of self, or a context.stop service, meaning if the service from the particular context, I shouldn't say view space, the context perspective, it can actually stop the service, or you can do it from a different, regardless of the context of the particular process. So content providers are only active when responding to content resolvers. Otherwise, they're sitting idle, waiting for something to happen, waiting for a request. Broadcast receiver, and they don't actually start. A content provider doesn't run in the background normally. It gets, you make a request and you create an object that's going to be providing the content from the provider. You go out there and you ask for it, and you do it by a content resolver, resolves the content, brings it back to you, and then that just goes to sleep. So it only wakes up essentially, or only is active when you're actually requesting something. Broadcast receivers are only active when responding to broadcasts, obviously. So if there's nothing to receive, there's nothing to do, which cuts down essentially on the processing. So you don't have at any one moment in time, because if you think of the design, if you had all of this stuff running simultaneously, in fact, the database is part of the content provider. It actually doesn't run all the time either. Nothing runs. So that's how you can actually multitask and have a lot of stuff loaded simultaneously, because you're not going to run out of memory. So you don't have like a state machine. You don't have like an endless loop going on where, constantly the content provider is servicing up stuff like in antiquated kind of older architectures. So even the services, they only wake up and they are only used when they're called upon. So the Android manifest. And just to summarize this particular concept, its main purpose in life is to declare the components of the system. So as we see actually at the beginning, most people don't really pay attention to it, but even the XML version is actually specified. Right now we're on 1.0. We haven't really progressed that far, but this is pretty standard actually in most XML related applications. And then we have opening and closing tags, as we've seen already, but here's the main purpose of the Android manifest, is to keep track of stuff like this. So this is an activity that's going on for this particular project, setting an icon, setting a label, so the icon for the application label. And this is just some stuff we've seen before, we have permissions. And actually your intents get put in here too. So if you're going to create an intent, you're going to have multiple activities or multiple classes that you're going to use as the program is running. You'd list them in the manifest as well. If you don't list them, then they don't work actually. So, and here's our intent filters actually. So declare intents handled by the current application in the Android manifest. So here we have action main launcher for whatever intent filter we're actually going to declare. And then, so here, the one down here for category handles JPEG images in some way. So it shows in the launcher. It's the main activity to start. So we say which activity is going to start, which activity is going to be the main launcher. Here's a bounce, and this is the name of the main. This is the image. This is the activity that we're going to do. So what we do is generally just list the activity names, which are going to be the names of your class files. You put them in here if you're going to use intents. If you're not going to use intents, you have to put them in here actually. But you put them in here only because the Android manifest, which acts like the traffic guard, is going to look and say, hey, is it okay to load this one? And it's going to, no, I have no idea who you are. No, we can't load you. So you're basically just telling it, hey, it's okay. We're a friend of the application. You can load us. So, which is essentially the concept. So, all right. So that was everything you ever wanted to know about basic concepts. So I've got 1, 2, 3 more little miscellaneous ones to go through. Although I don't know how far I'll get. I can save one for next week as well. So we'll see. I have to figure out how to open this in office.org. Let's see. Let's just do it this way. I believe I want GUI. Yes, I do. All of these are about 3 or 4 slides. This one's like 8 slides long. It's not too bad, actually. But to go over some miscellaneous... Did we cover this already? We covered layouts, didn't we? I believe we may have covered this one. Maybe even last week. Widgets, menus, layouts. Does this look familiar to anyone? No? All right, let me just briefly review the GUI components then, assuming that we're going to spend this for a little closure summary / of the course. Or first-time exposure, familiarizing yourself with the main types of GUI components. I think I did the view hierarchy. I remember doing this in this class, but it was several different weeks ago. So this is another little review for your final then. Know the hierarchies. You're welcome. So all the views in the window are arranged in a tree. Here's the tree here. We have views and view groups. View groups hold views, and a view group can hold a view group. So the concept of the group is a grouping of views. The view itself is generally holding components which end up in the group. Everything is arranged hierarchical. From the main, you can have multiple different hierarchies, and they're usually held in different XML files. And that's basically how you're going to separate things out. Why you're going to separate things out makes it easier sometimes, actually, to configure the components. So you show the tree by calling a set context view to the root node. You can set the context view to the view group, actually, to another view. And that's how you switch between different contexts, actually, in the particular activity. So here's a little example here, a little screen. It's got a bunch of items on it. And these are the items that are in the views. The items are buttons and text boxes and things of that nature, and lines. There's some actually horizontal lines and edit labels, edit texts and text labels and things. So I know I gave you this stuff before. I talked about layouts. I know I gave you this stuff. In fact, we talked about layouts even as close as last week, I think. But some of you may not have been here. It defines how the elements, so we have the layout. It defines on how the elements are positioned. Remember I talked about relative layout, linear layouts, stuff like that? Yeah. And each element that are positioned relative to each other. I even mentioned, I think I like the relative layout, because you can say, put this button to the left of that button, and put this label to the right of that other button and stuff, and you can actually specify the position. Otherwise, if you do a linear, they go in a line and then they word wrap all around. There's no control. But if you just have like a view, like a, I don't know, web view or something, or an image view, I know I've mentioned those in this class, you can put that inside the layout and put a label on the top, and there you go, you have a web browser, which is what you're looking at. So you can have different layouts for each one of the view groups. And the widget, maybe this is just the terminology for you. In terms of the widgets, they are all view objects, or widgets by concept. So example, text fields, edit fields, button, checkboxes. So on the exam, I'm probably going to ask you questions about views and layouts and widgets. A widget goes inside of a layout view. True or false? Yes, widgets go inside of layouts. You can put a layout inside of another layout. True or false? True? Yeah. Yes. Yes. A view group can have another view group inside of it. True. Yes. All right. And everything can be nested. You don't have to use a hierarchy. False. UI events. So we talked about these. I know we talked about these, but review a little bit. Last time we should have talked about this stuff. On-click listeners, on-touch listeners, on-key listeners. You know, the interesting thing is you can actually use them interchangeably. You can have a button and do an on-touch listener, or you could do a, actually, here's the trick. Some buttons take the on-touch listener. Some of them use the click listener, on-click listener. And I've noticed this recently with image buttons. Only respond, although you can create an on-click listener, the on-touch is the only thing that's going to respond to it. I'm not going to ask you a question of that detail. You don't have to worry about which button types, because we have the button, we have the image button, and then on the image button we can turn a non-image button into an image button just by taking the text off and loading an image in the background of the button. You know, you don't have to worry about that either. I'm not going to tell you. I'm not going to trip you up with questions like that. But long story short, I've recently realized that as the APIs get older or newer and newer, certain events only work with certain types of buttons now, which makes it interesting. In fact, maybe you all have kind of familiarity with the concept of visibility in terms of the view. So a button has, you can set the visibility to true or false, or you can set the view.visibility. You can set it to invisible, or you can set it to gone. They all mean different things. This is where you get those big old books and you look up that stuff. So, but this will be a closed book, closed notes exam, so you won't have to look up this level of detail. But Knowing the concept of a UI event is important, and the event listener. So usually handled by defining a listener for the form on something. Listen for this, registers it with the view. So it says, and each one of the items in this particular list here all have their own listeners. Or you could create one listener for each one of the events and then specify out in a case switch as an example, or an if-then kind of statement. This one, this one, this one, this one. Put them all together if you want. But each one of them has a defined a role that it's going to play in the system, and has defined activity that's specified per the events, and the events are all different. So in terms of the on-click listener, handled for clicks on a button or a list. Well, how do you click a button when the button is on a touch screen? But it still works, actually. You can still click by pressing with your finger. But that event is actually different. So the on-click listener actually works with a traditional style button. When you get into the image buttons and images themselves, you can turn an image into a button by attaching a touch listener to it. So you have an image that you're showing on the screen, and you actually, in an image view, you can actually map that out. Sort of like the way you do an image map in HTML. And you can say, on this touch here, on this touch on the regions. And then when you do that, you essentially have this pretty interesting button, essentially. It's an image button. On key listener, for handled key presses, what's that going to be? Well, probably on a text box, text input. So, alternatively, you can override all the existing callbacks, and if you implement your own class extending the view. Actually, I didn't mention it already, but you can actually create your own widgets. You can create your own. Let's say, for example, you want to create one of these items here, and you want to put HTML text in here, not regular text. You just make an HTML text box, or text field. I call it text field. I keep calling it text box. And the text field itself, you can override just by inheritance. So that's one of the best parts about Java. It's easy to inherit from. So menus, I think we looked at this last time, maybe. I don't know if we talked about menus or not. Options menu, context menu, submenus. Didn't really look at submenus, I know that for sure. That's why I kind of like this lecture still, because the submenu is part of the main menu. And you put menus inside of the menus, and you can nest them hierarchically. So options menu shows up on the bottom of the screen. Context menu shows up in the middle of the context of the screen. Context menus are interesting because as you're placing touches on the background, on the context, it's per context. So if you have a view up and it's showing this guy here as an example, you touched it somewhere, you can actually have a context menu show up automatically anywhere you touch on that view. Or submenus that come from touches that are on context menus. So submenus only come from context menus. So you can actually load a submenu actually without loading. In fact, you can have these come up automatically as well by clicking on on load events that say on the view load the context menu. And so it'll show the context menu up automatically. So here we have kind of the way that this sort of menu item with a menu item and a submenu kind of works together. Has 0 or more items, has 0 or more menus, 0 or more. So submenus can have menu items can have menu items in terms of the hierarchy. So again, it's hierarchical in terms of its context as well. See, I told you it was painless. 2 more, they're also painless. Menus and the local concept, actually. If I can figure out how to load these suckers, let's see. Open with. See, when I do that, it doesn't open. Actually, I have to go up here and say open. I believe I probably have to get an updated version of this. Open Office. Actually, this is Neo Office. This isn't even Open Office. So. 13 slides, not too bad. This is good prep for you. And then during the week, I'll be putting these up on the website, and then I'll basically show them to you next week, which ones I have up there, so you can go through which ones you've missed when you haven't been here. Creating applications that support options, subs, and context menus. This is actually a continuation of the previous lecture I just gave you a few minutes ago. In terms of the displays, we know that we've seen the toast, I hope. So what is a toast message? It's a message, dialogue message that shows up on the screen. It shows a piece of, usually a sentence. You're not going to use a toast message to put an entire paragraph up there. It's going to be like, log in, idiot, or something. It's going to be something simple, hopefully. So display a message with a menu click. We can do a, home button was clicked. In terms of this is what's called the toast message. Actually, it's not labeled on the slide. This is the options menu. When you press the options hardware on the phone, here's a sub menu that comes up that you can actually do from an options menu. You can do a sub menu from a menu. You can do it from the context menu as well. It doesn't actually have to be. So the previous lecture that you looked at had sub menus coming from context menus. This is actually coming from an options menu instead. So plus a menu also opens up a sub menu, and then we have automatically filling in items, let's say, in an edit text menu. That's going to come up with a context menu. It's also possible. And here's our menu composition, where we have the options menu here as an example, and we can have sub-menus that come off of this as an example, this plus menu. And this is this stuff here, plus, previous, next, home, in terms of this layout of this options menu down here. So it can open up sub-menus, and these are the options menu that open up sub-menus that are going to essentially show different information. So this is the context from the edit text. So usually what ends up happening is you'll have a list, and then on the list you can have that populated into a menu as an example, and that menu can be used for, which one of these do you want to delete, or something of that nature. So here's creating a hello menu project. If you were going to put one together, you can actually automate the process by using some of the built-in tools that come with the API. So you can create the two text views and an edit view, and then create a menu folder. Menu folder, believe it or not, is still not created automatically for you because not every application has a menu. So you actually have to create, in fact, you have to create other folders like raw as an example, going back to what I gave you a couple weeks ago on storage. If we have raw text files or data or MP3 files or something that we want to store, they are found in a raw submenu, but where is that? You have to create it. So same thing with the menu. So you create the menu.xml file in the res menu, new other Android XML file. So you can use the tools to automatically generate the menu. The menu will be saved in the menu subfolder. So you can create it, put it in the resource menu folder, and then you use it just as if it was the main menu, main.xml. So in here, our menu, we can use the GUI tools or we can use the XML editor to add items to the menu. So you define the options menu and the sub-menus in the menu, or you can actually separate them out. You can have more than one menu file. So when they're in different contexts, it loads different options menus or different context menus, which is kind of interesting as well. So here we have a sub-menu item that's in here. Here we have our menu with our items, with our sub 1, sub 2. This is building that example I showed you in a couple of slides ago. Here's our options menu items here. Item 1, item 2. It's associated with icons that are associated with the plus. I think it was called home, pre, next, or plus or something. Those options. And that's showing you where these icons are loaded from. So that's basically the XML menu XML file that loads this here. It's for this options menu. And so that's what it looks like essentially. And defining the context menu for the edit text is pretty much done in a very similar fashion, where we have the this part of it here that's essentially being created. And then we can have this concept called the strings, and we've seen the strings before, and hopefully you're using strings in the applications you're building for these programs that are due all on May 1st for this course. And what are the strings? It's like holding a variable. If you think about the concept, you're storing information, associating it with a name, and you're using the string in here actually, where it says string, so at string, / hi message. Well, that's one of these guys in here. Here's hi message right here, and hi message is going to be hi with a string. It's going to be it's an opening and closing tag for a string. It's going to say hi exclamation point. So if you do this, it makes it really easy actually in terms of creating variables. You know how people used to define stuff at the top of the program when writing their source code? It's really the same concept. So for example, you can say, pi up there, 3.14, and then maybe we make it a double or a float or something, and then further down in the code use pi. So if pi changes on you, which it never does, but if it does change on you, you go up there and you can change it. Maybe interest rate's going to change on you or something, so you can change all in one spot. Well, people go and do the same thing with strings. So we have a string called the application name. So you want to change the application. How many times are you going to put that name in there? Who knows? The name's going to be, you're going to advertise your app all over the world. Every screen's going to have your name on it or something, right? So if you put it into strings, you make it a variable in the strings, you just change it one spot. Makes it kind of useful. Also, another use for it is for multilingual programs. Let's say you build an app and it's in English, and you decide, well, I want this to be in Spanish. You can use the next lecture, which is going to be on localization, and just reset the localization, which will take all your English and change it to Spanish. Or you can use it in the string menu and have multiple string.xmls for different languages. So one's French, one's Spanish, one's English. So you press the flag at the top. You ever seen those programs? You press the flag and it changes. It's just switching string files or switching the localization. I'll talk about localization in a few minutes, actually. Icons, replace icons that are used in the menu.xml and the resource drawable we've seen so far. And then, notice there's like 3 or 4 different drawable directories, and those are different screen resolutions. If you wanted to get really fancy, you could create ones for high definition, one for low definition. Most people don't take the time to do that. They just create an icon that looks good on all screens and put it in the default. And then if you just put it, in fact, we don't have a default drawable anymore. In the old APIs, we had a default drawable. Now it's drawable-HD something or other, or dash VG something, or it depends upon the monitor resolution that you're selected. It would actually pick the appropriate drawable directory to pull the icon from. So it depends upon your goal in terms of how fancy you're making your icons, I guess, or how you want your icons to look. So you download the icons at, well, anywhere you want. You stick them in here in the drawable directory. Here they are here, HDPIs, IDB. We don't have a default drawable anymore, though, but you can actually create one if you wanted to, and it would have the same effect. But the current Android projects don't do that for some reason. We know about inflating an option menu source, maybe. Well, we know about inflating resources, r.whatever, IDs. We inflate them to draw something in a text field or in an edit field to get information. So set the text, get the text from different GUI items. Well, the same thing can actually be done for the onCreate options menu. So in terms of inflating a menu resource, we can inflate menu.xml, that menu we just saw, add an onCreate options menu, setting it the menu in the main activity, so the items will appear when you touch the menu button. So we inflate it the same way we inflate to use, but we're using it to inflate to say inside of the onCreate method, use this, basically saying you can have multiple different options menus, and this is the one I want to use for this particular onCreate method. So here we have the basic menu inflator, get menu inflator, and here use it from the R menu, so which is the resource menu directory. So if you haven't noticed, actually this hierarchy for the path is set for each one of your subdirectories. So we have string, r.string, r.drawable, r.menu, which is giving us the location for the particular resource inside of the resource subdirectory. So responding to user actions, as we've seen so far, we can respond to on-click events, on-touch events. So what do we do with the menu? Well, on options selected. So on options items selected, we have from the menu, we can basically come up, and this is actually done in a very traditional style using a switch case format, which is what you're going to see more often. You could do it with an if-then or if-else kind of format, but it's usually done this way only because it's a little easier to visualize. It's less code writing as well. So if it's item.get, the item ID. Well, each one of them, you can set the item ID actually. It starts out just like an array, 0, 1, 2, 3, depending upon how you have them arranged on your options menu. In here you can actually just, get the ID, which one did you pick? And this is just putting a toast message out, so toast make test, plus button was clicked. next button was clicked because we got the ID and it was a menu item next, menu item plus, and this was the item that was from the ID that was defined for each one of the options. You can use numbers, you can use text, descriptions, you can use anything you want to keep track of them, but what you're doing is just figuring out, well, which one was picked, and then from the case switch, you're basically putting up a special message or doing something. You can register the view for a context menu, so by calling register for context menu, passes it the view, so it's an edit text. In this particular example, edit text here, m out edit text. And you're going to assign to the context menu. So you're basically associating it. So when this viewer receives the long press, it's going to display the context menu. So this is how we get the context menu to appear on different screens, on different views, by just setting the context, essentially. So here we have the code for it, register for context menu, this menu, for this particular view. So that way we can have multiple different context menus for multiple different views, which comes in handy, hopefully. So you can define context menus appearances as well. You can actually, there's not very much you can do with it, but you can change the style of the box, the dialogue kind of thing. You can change the items on the context menu as well by overriding the activities content menu callback method on create context menus, which says up here, so look cut off for some reason. I probably need to edit the slide. So on create context menu, here we're going to inflate the menu context menu and treat it like the menu. The behavior itself here, we can actually kind of switch it around by overriding the activities menu. Menu selection callback method for the context menu on the on context item selected. So on this particular item selected, you can actually change what appears. So it says on, off, or toggle something. Or you can actually just say, well, then if this happens, then use a case switch essentially and fill in the behavior that's associated with the particular item that was selected. So that was number 8. We only have one more, don't worry. I'm not going to keep you that late. I can just figure out how to open up files. Let's see. Open. Last but not least, and this will get us through the entire content of what we were supposed to do, we didn't talk about localization yet in this class. Localization is actually pretty easy. It is, how do you tell what language we're using? When we can actually set the localization instead of using the string XML interface. So learn how to localize an application. So this one's in Bonjour, this one's in English on one side, and it looks like French on the other side, or no, it's like French from Canada. It's a Canadian sign and a European sign on the UK sign on the left. So here in our resource, we have strings, and in our strings we have the application name, and we have a shall I compare 3 to the summer, and this is shall I compare thee to a summer's day. I guess it's a poem. Anyway, long story short, this is the English that is appearing in the strings.xml file, and we have all of this stuff, even the flag here from drawable flag. It's also specified in here. And then we have different localizations. So if we set the different localizations, we can automatically switch the languages. And it's all done. And this is another reason why you want to use the strings, because then you can switch it, and then you can in one place you've got it all translated. I mean, you don't want to go through an application and build multiple different versions of it using a text editor, or using the menu editor, or using the XML menu interface editor to change all the text on all the labels and everything on the buttons. It's just ridiculous. So you use a string for it all. So localization here in the local code default, and here it's English. So we have different ones we can set. So we can change the locale to English US, Spanish, Valencia, Spanish for Spain, different languages for different regions, for different countries. And I'm not familiar with every single version of Spanish from every single country. Neither is anyone really, probably, unless you speak Spanish. Then you know everybody. You know what everybody's accent is by the way they speak. But how can you tell in the program? So anyway, you're basically changing the localization is what you're doing. And you're using the string to do it. string XML file. So, as promised, you see that was painless. It's 5 slides of painless lecture. So, and we're actually getting out on time, good, for some of you who are concerned. So, next week, if you came in a little bit late, make sure to sign the roster. If you came in a little bit late, I also announced at the beginning of the course that next week, and sometime during the middle of this week, I'm going to upload all of the different lectures that I've gone over that may not have been in bhacker.com and may not have been in the EMS, actually. I'm going to populate all that stuff for you. Go through it, I'll sort it out, write the exam. It'll be a brand new exam, not the one that some of these people have been taking early. Because that's all over the internet probably at this point. And it'll be multiple choice, don't worry about that. But next week I will have the exam written after going through all this, and I will tell you which lectures to look at and which information to study. Because as you might imagine, it's a huge subject area. It's like, you know, I know there's not going to be any programming on it, but, you know, it's probably a good idea to pinpoint a few areas that you should concentrate on in terms of preparation. And then the exam itself, just refresh your memory if you're not in the loop, haven't seen you in a while. It's not next week. It's coming up, though. It is not on the 16th, it is on the 23rd of this month. So it's not next week, but it's the following week. This is the 23rd is when we're supposed to have this exam. If you don't like the 23rd, you can take it on the 25th if you want to. But only the 23rd or the 25th is available. I am giving out an exam this weekend, but you're not going to have any study aid for it. And it's a harder exam than you're going to take if you take it on the weekend. So I'm not prepared, actually. The Unix exam is this weekend, so I'm not prepared to have either the Android or the iPhone ready this weekend, so you can't take it. You have to take it on the 23rd or the 25th. So. Questions, comments, or concerns? No? And you guys all finished all of those assignments that are due on May 1st? And you uploaded them into the EMS, and you're not all going to wait until the very last week of class. Because you know what happens when you wait for the very last week of class? They're not getting in. And then you're going to have, you know, beg, plead, you know, oh, there was an EMS error. That's because you waited till the last week of class. So wait for 2 weeks before, at least. I mean, at the most. Don't do it past 2 weeks before, because then it's not going to work. So. All right, thank you. See you next time. See you next week for the final exam review.